Hi all, welcome to the third part of the video lecture on ER-to-Relational model mapping. So in the previous part 1 and part 2 we covered in detail how this ER model can be mapped to relational model. So through a systematic algorithm. So the first step was about mapping of the regular entities. Then we discussed how we can map the weak entities. Then about the relationship, that it's a one-to-one relation we discussed with the three approach. Hope you remember: Porigi approach, merged relation approach, and relationship relation approach, something, or cross reference, the third approach. And then that one to many relationship, that can be mapped to a relational model through Fourier approach or a cross reference approach. Now it's time for us to move on to step number 5, where we will see how this many to many relationship or M to N relationship can be mapped. Okay, so we are focusing on the many to many relationship. So this is interesting. See, there is only one option for this out of the three cases. Even though we discussed in one to many, one to one, we have three option. Hope you remember, like Foringi, merged relation, as well as a cross reference. Now the last approach, that is a cross reference method or relationship is the only one approach here. Okay, so we will understand why not that foreign key approach, because foreign key approach is something that we used for both one to one relation and one to n relation, but we can't apply it here. Okay, so we will see the reason with an example. So let me explain. This works on relation, that is the, hope you remember, employee works on project, right? So which is a well-known example for this many to many. Not like well known. This is something we discussed. That's all. Yeah. So one side we have this employee table, and other side we have this project table. In between we have the relationship, that is works on. Okay, employee works on project, like that. Project, and now you know that one employee can work on n number of project, and also one project can have n number of employee, many, both. So one employee can work on many projects. So let me denote that many by m as a variable, and one project can have a many number of employees. Let me denote it by mn. So this is mapping of m is to n relation is what we are discussing. Okay, so now what you have to do is what we are it's mentioned like the only one approach is you just go for the third option, right? As per the one to one relation. So third option says that there is an entity, there is a relation for this employee table. So you know the employee table, let the attributes be employee number. Employee number is that SSN, right? We can denote like that, what is used in the textbook. Okay, so that is the key attribute, right? And now there are many attributes we can think of, like employee name, okay, employee age, address, etc. I'm not denoting all of them. And now works on, also we can think of one employee is working on a project in a week, how many hours he is working, something we discuss like that, how many, the number of hours in a week a particular employee is working on a given project, something like that. Now what about the project relation? We can think of a project number as a key here, primary key here, and name of the project, and many other informations about the controlling department, like that, many things you can think of. So now when you are asked to map this, what you have to do for this employee table, you come up with a relation. Okay, so this relation will help you to map everything from the employee table, like SSN, employee social security number, the employee name, and other fields. So let me give a space here, so just to highlight some violation cases and all. So here we assume other fields are coming like this. Okay, so this is a key, and similarly for the project table you have to maintain a separate table. Okay, so that is just like how we are mapping the regular entity, just map all the symbol attribute and composite attribute, split and map. Okay, like that. Okay, now this will go like this. Now what you have to do for the works on, so this is very important. So in the previous two cases, this third option was something like optional, but here it is mandatory. For m is to n relation, the only approach we can follow is relationship. So here works on is a relation approach, let me call like that. So what I mean by this, is for the relationship you have to maintain a separate relation or a table. Okay, so you are going to maintain a table for this works on relation, just like you are maintaining a relation or a table for this employee entity and the project entity. So here you are maintaining a separate relation for the relationship works on. Okay, now what are all the entries here? Okay, so this is something, so definitely all the simple attributes of this works on relationship will be coming here. Now in addition to that, you have to maintain what the primary key from both the sides of the entity, like from employee table, what is the primary key? SSN. So let me just rename like this, and project number, like that. Oh, it's not about I mean, even though you are not renaming, there is no issue. Just for differentiating, I'm giving that name like that. Okay, but what I mean is the same field I'm keeping here also, something like this. Okay, yeah, now it's interesting. So what I done is I underlined both of them. So is it needed, like what about the primary key? So first you have to add, so the underlying part we will see later. What about the primary key here? The first step is you take the primary key from both the employee table and project table and add it into the work zone relation as a foreign key. Okay, so now what you can see is this is important, and also this hours, right? So let me use this hours field of the number of hours, something like that. So this also I am keeping here. Okay, so that about it for the time being. Now this is going to, this employee SSN, this is going to act as a foreign key that references the primary key employee SSN. I am denoting here, actually it should come here. Okay, now similarly this is going to act as a foreign key that references this PNO. Okay, this particular column, like that. Okay, now what about the primary key? We will see. That's for each of the MEs to N relationship R, create a new relation. So this is the only approach we are having. So we have to create a new relation for this relationship. So this is the third approach, the cross-reference approach, that includes as foreign key attribute in S, both the primary key of the relation. So that is why what we added. Primary key from employee table and project table we added as a foreign key in the other one. So their this is the point I want to tell. This their combination will form the primary key of S. So this is important. So what is primary key of this one is because this combination I want to make as a primary key, something like this. Okay, so or what I can do is separately, let me highlight it. So the primary key is this one and this one together. Okay, why it is so? Because if you are looking at the employee, employee SSN field alone, you can see that one employee can work on many projects, right? And if you focus on, so let me take some examples. So this is my why both of them together acting as a primary key, that is my question. So this is employee SSN 1, and this is a particular project number, say 2000, something randomly I am giving. So employee number 102, so here I have some 3 employees, something randomly. Okay, so 4 employees. So here projects are like project number 202, 201, 202, 203, 202, like that I am denoting. Now what I am highlighting is this employee number 101 is working on project number 2000. Okay, now employee number 102 is also working on project number 2000. Now this same employee 101 can work on project number 2001 also, right? So that is his choice, right? Now 103 is also working on 201, like that. So now what you can see is employee SSN alone, if you are making it as a primary key, this is repeating, right? Because here 101, here also 101. But what I mean is they are working on 2 different projects. Okay, something like that is not captured if you are making this one alone as a key. Okay, so that is repeating, because key value is not supposed to repeat, where you are not supposed to make employee SSN alone as a key. Similarly, if you are looking at a project number alone, this is repeating. See, because one project can have many employees working on it. Similarly, one employee can work on many projects. So that is the reason. So that's why you are forced to make the combination as the primary key. So when you take that employee SSN and project number together, it is not going to repeat, right? So 101, 2000, that is not going to repeat. So that is a single instance, and there you can very precisely mark the hours, like this particular employee working on this project and how many hours, say, per week, like that. What you want, that you can store accordingly. Say some he worked on this particular work, say some 15 hours in a week, like that you can very precisely keep the further information. Okay, so now it is very meaningful. So that is what I want to highlight, and also include any simple attribute of the many to many relationship type as an attribute of S. That is what we seen, that ours. Okay. So notice that we cannot represent the M is to N relationship by foreign key approach. Now you tell me why this is true. So this is again very important. We can't represent M is to N relationship type by a foreign key approach, because for previous 1:1 mapping or 1:10 mapping we saw that the foreign key approach is a preferred choice, right? Where here it is not. And the explanation they are written like a Mystery cardinality ratio because of that. But anyway, I just want to want you to think about it. Okay, so why it is so? From this example, you give me a justification. So pause for a while and think of it. Why you can't use that foreign key approach here? So if you are trying that foreign key approach, what will happen? So that is what I want to know. Okay, I hope you can pause and think about it. Okay, now come back. Yeah, so just take an example, like what I can do is the foreign key approach. What you are doing is you will take the primary key of one of the table and you will make it as a foreign key there. So let me do like this. So I am taking this SSN and I am putting it as a foreign key here. So this I am creating an error case. Okay, so let's see why it is so. So employee SSN, when I am keeping this as a foreign key for this, something like this, so this is an error case. Actually you should not do it. Okay, so what I am trying to do is I'm trying to keep all the employees who are working in project number 2000 here, right? So you can see that project number 2000 here, 101 is working, 102 is working, and also many more people are going to work. So in this particular row you can see there are many, I mean now it is a multi-valued attribute, right? We don't want it because we already told I already told you, because that's the basic characteristic of the relation. That time itself relation is not supporting composite or multi-valued attribute, because that create unwanted complexity. We don't want it. Okay, so we will always try to avoid it. In ER model, multi-valued attributes will be coming, and we will see how that multi-valued attribute can be handled. So that is the next step of the algorithm. So that is the last thing. But anyway, at this point we don't want to create it further anyway. So that is why. So now it is looking like a multivalued attribute, because the same project many employee will work. We don't want it, right? So we are not going to add as a foreign key like this. Now let me tell you the other case also. So we will not do it. Okay, the other case is like say you can put this for primary key, you can put as a foreign key here also, and you can make a reference like this. Now also the same issue, because when you look at employee number 101, he can work on project number 2000 as well as 2001. So many entries. So now also it's a multi-valued attribute. We don't want it. Okay, fine. Hope you understand this. Let me remove this error cases. Anyway, so that is why we are not using that foreign key approach. Instead we stick on to the last approach, that is the cross reference approach, or the relationship relation approach. So hope it is very clear to you now. Okay, now the last sixth step is about mapping of multi-valued attributes. So we already saw many cases we are trying to avoid this multi-valued attribute. Now if in the relational ER model itself, if there is any multi-valued attribute, hope you remember, like in our department table we have this okay, let me take it. If you are looking at that department table, department entity, okay, you can see that there are many attributes, like a department number is there, okay, and department name is there, like that many attributes are there. And in addition to that we saw something like when we designed that ER model, we observed that there is department location also. So what we mean by this, in which are all locations this department is located, that is what I want to. So this is a multi-valued attribute, and typically we denote multi-valued attribute like this. Now how you can deal with this, that is the question. So when you are mapping it as a regular entity, okay, so when you are mapping it as a regular entity, what you have to do is you map all the other entities. For example, here this is a key, right? So this key value, this department name, okay, everything you have to map, etc. But you should not map this multi-valued attribute. Okay, now instead for this multi-valued, so this is for the department relation entity. Okay, you skip that multi-valued attribute and keep all other attributes in this table. Now for the multi-valued attribute, that is department location, okay, maintain a separate table. Okay, you can give any name. for this exclusively you maintain a separate table for that. I mean, just for an attribute you are maintaining a separate table just because you want to avoid this multi-valued attribute in the relational data model. So that is something very important, because when it comes to implementation we don't want that difficulty, because if you want to implement this multi-valued attribute instead of a single cell, we need an array kind of thing. But you can think about such a data structure, that is okay. Maybe in recent cases people may be thinking like that, but if you are looking at the basic relational model or the flat relational model approach which we are discussing, I mean as part of your course, this is not something, I mean we don't want this difficulty. But at the same time you can think like what is the problem with the storing an array inside a record, right? A particular cell is having an array where multiple values I am supporting, dynamic array I can keep. Okay, so possibilities are there, but in the basic relational model is having the assumption that it is not ready to have that difficulty, so it is not ready to handle it, right? So the for this multivariate attribute department location alone, you are going to maintain a new table. Now how this table will look like? So first thing you have to do is the parent table is actually the department table only, right? From there you are getting this department location as a field. Now from the parent table, look at the primary key, put it as a foreign key here, so as usual, okay, because then only this reference, I mean you can keep that relation like it is from that department table. Now in addition to that, you will keep this department location also. So okay, now how you will handle? So this will now act as a foreign key that references the primary key of the department table, so that that reference is now maintained. For example, I have department number 5. Department number 5 is located in, say, Mumbai, okay, something, and the same department, suppose it is located in Hyderabad also. Now you can maintain like this. Now you have another department, so here you don't have to repeat this entry or nothing, simply repetition will happen here. Now this is a small thing also, right? Now there is another department, the department number 6, it is located in Hyderabad. Like that you can maintain the information, and other locations also, any number of locations, same department located on, it's a multivariate attribute, right? So the location may be any number. Same thing you have to deal with, like a mobile number, whatever be the multivariate attribute. This is the approach you have to use. Okay, now tell me, what about the primary key? Because when you have a new relation, you have to think about the primary key, right? Can I make this department number alone as primary key? It is wrong choice, because it is repeating. See, I don't want it, right? See, because same department can have multiple locations. Similarly, can I make this department location as a primary key? No, because this same location may be shared by multiple departments, right? So but if I'm taking these two together, it's a good choice, right? So the primary key of the new relation, I mean the newly introduced relation, let me write like this. The primary key is now this department number and department location together. So this is important, why I chosen like that. So something similar to here. So here also the primary key is chosen to be employee SSN and the project number together. Okay, so that is what we mean by, and you understood why it is so, and here also why it is so, right? So together it is not going to repeat a particular department 5 in Mumbai location, that whole information we are not going to repeat. Okay, and now if you want to know more details about department number 5, you can refer here. Now it is a separate relation, right? So the problem is solved, and the attribute is no longer a multi-valued attribute. Now for all single value we can maintain separate row, but for that we don't see, if you want you can maintain separate row here also, but it will take too much space, right? Because department entire location like address, everything we are storing here, everything we have to repeat, right? So we have to reduce redundancy maximum, so that is why we are introducing a new table like this. Okay, so it's a very nice thing. So for each multi-valued attribute we have to create a new table. So this relation R will include an attribute corresponding to so what we done is let A be the multi-valued attribute. For that multi-valued attribute alone you create a new relation. Now all the attributes of, I mean this multi-valued attribute you have to add as attribute in R, right? And the primary key of the parent relation, right? You have to add here as a foreign key. Okay, that's all. Now the combination of this A is a multi-valued attribute and K is the primary key which you added as a foreign key here. So together it will act as a primary key. Fine. So the example you can think of. And one more thing you can keep in mind is what about delete operation here? For example, if I want to see, if I am deleting something like this, I am deleting this department number 5 from here. Okay, so there are many people referring this 5, right? The best thing is you have to use that, I mean this entry, because whenever you are deleting the department number 5, you have to delete those entry from here also. Otherwise it is meaningless. Later on when you are referring this department number 5, it is no longer available, but you are simply keeping their location information here. That should not happen. So whenever you are deleting something from the referencing relation, that is a department here, the corresponding entries in the sorry, when you are deleting something from the referred relation, hope you remember that terminology here. This so what I am trying to say, so with respect to this particular foreign key, you can see that this department is the referencing relation, which is referring this department table and which is acting as a referred one, right? This is a referred relation. Now whenever you are having such a reference from here to here, what you have to do is that reference should be meaningful, right? So when suppose you are deleting some entry from the referred relation, you have to enable that cascade option so that these entries will be deleted here also. Otherwise it will not work, or it will create some unwanted difficulty. So the propagate or the cascade option for the referential triggered action should be specified as whenever you are having that schema design, that time itself you can specify along with defining that foreign key. So this is applicable for both on update as well as on delete. So whenever you are updating some entry from the referred relation, as well as whenever you are deleting that referred some entry from the referred relation, this may create issues. So to avoid it, you can do this cascading option. Fine. So the illustration of some mapping steps is highlighted here. So this is something over time we discussed all this, like the regular entities. This is the first how this regular entity, step number 1, employee, department, project, how we mapped, and what about the foreign key, everything is clear now, right? So now that weak entity, that was our step number 2. In our example, the dependent was there, and when I explained that, this I explained separately, like how this dependent can be handled. The corresponding identifying entity is employee. From there we taken the primary key and made it as a foreign key here, and this one and the partial key together we made as a primary key. Hope you remember. Now this is about many to many. So this third one is like a relationship on relationship. I mean step number 5, how we will deal with the M/N relationships. That was our step number 5. So that works on was a M/N relation, where we made a new relation for that, right? So where, and the primary key from employee table and project table we made as foreign key here, something like this. And this is how we dealt with the multivalued attribute, like the department location, department number, and department location together will act as a key. The same example. Okay, so this completes the whole thing. I mean, so like that they can give you any ER model, or sometimes they may ask you to draw the ER diagram, then you do this mapping and show the like that. Some questions also they can frame corresponding relational table. Okay, corresponding relational model. Now one more last step, but it is not an obvious thing. Mostly we are dealing with the binary relation only. Now suppose you have an N-ary relationship, what you have to do? For example, the hope you remember what was it. So that mapping is shown here. Hope you remember this relationship. Something I taken as an example for a ternary relationship, and it was that supply, right? And for that supply relation, we have a supplier at one side, supplier, and there is a project at the other side, project, and part was there. Okay, so where you will keep information about each and every parts. Now one supplier is supplying a particular part to a project, like that this relationship is working. So it's a ternary relation example. So let's say that the supplier S is supplying a part P to a project J. Is a particular instance of the supplier table, let it be S, is supplying a part P for project is supplying a part P, okay, to project J, something like this. Okay, so that is how this ternary relation is working. Now to handle this ternary, so like that for N-ary relationship also, what you have to do is you have to create a So just like how you are dealing with that many to many relationship here also, because it is relating many tables, right? So it's not good to keep then separately on foreign key approach you have to apply between this, that will create unwanted complexity, and it is not a preferred approach. So what you can do is maintain separate entity for the supplier relation, separate relation for the supplier entity. Similarly, for part entity, maintain a separate relation or table. Project also you maintain a separate relation or table, something like that. So this is the table corresponds to supplier entity, project entity, and part entity, right? Now for the relationship also you maintain a new relation. So the method we are opting is the relationship relation approach. Okay. So it may be written somewhere here. So the third approach, something like that. So we are going to maintain, so let me write it. So this is a, what is this? This is a relation that corresponds to a relationship, right? The supply relationship relation, or the cross reference thing. Okay, so the last thing we discussed. So that is what you are maintaining. Now from the supplier table you just focus on the key, supplier table. I think supplier name was acting as a key. Okay, so whatever it is, in that example it was like that. Similarly from the project table, project name may be unique. Okay, project name. Okay, and similarly from the part table, part number was there, right? Part number. So this is what is acting as a key from all of them. Now all these primary key you choose and you make it as the foreign key here in the supply table. So in the supply table there will be an entry for the primary key of supplier relation, that is S name, and take the primary key of project relation, project name, and take the primary key of part relation, that is this part number, put them all and make them as a foreign key that is referring to the respective relation. Like this is going to make a reference with the supplier table, and this is going to make a reference to the project table, and this is going to make a reference to the part relation, right? And similarly I think this quantity may be an attribute of the supply quantity, like how much quantity of supply you done. So that is a relationship attribute, that also you can put, right? Now together all these three will act as a primary key of the supplier relation, because if you are looking at supplier name or project name independently or together, that can repeat. You just think of examples you will see, but all together it's not going to repeat. So that is why all the three together become. So this is a general idea. If it is an N-ary relation, all for that N-ary relationship maintain a new table. So there will be n entities participating in the relationship, right? From all these n entity, pick the primary key and put it as a foreign key in the N-ary relationship, and together it will make the make the primary key of the new table. Okay, so that is the idea. So just go through it. We use the relationship relation, this concept, third concept we discussed before, for which the N-ary relationship end, we create a new relation, include as foreign key all the primary keys of the relation that represented, and also include the symbol attribute. The primary key of the new relation will be combination of all this. Okay, just read it. Now let's conclude here. So the hope you remember the entire mapping procedure. We systematically explained it using we examined that procedure using some 7-step algorithm, right? Where we saw how that regular entity can be mapped, how that weak entity can be mapped, how that relationship, particularly one-to-one relation, one-to-many and many-to-many can be mapped, and then multi-valued attribute, and finally the handling of the N-ary relationship. That is the procedure we did. And for every entity type, regular entity type, there is a entity relation, some relation we define. Similarly for one-to-one and the preferred approach is the foreign key approach. For many-to-many relationship, it was the relationship relation approach, and for N-ary relation also the relationship approach, and that's some n number of foreign key. Here this 2 foreign key, hope you remember. Simple attributes of the entity will be attributes in the relation model also, and the composite attribute will be set of you will decompose and you will add one by one in the relationship, right? And multi-valued attribute, there is a new relation, and some foreign key kind of approach we used there. Here we have a value set. The equivalent terminology in the relational model is domain. The key attribute, here we have a primary key as well as a remaining key called as the secondary or alternate keys, or some unique attribute. Okay, so that completes the relational model mapping, that is from ER model to relational model. Okay, so that about it. Thanks for watching. Doubts if any? So the thing is that you have to work out in your own way by taking suitable example. Everything will be clear for you, and listen to my video once again if you are confused. And still, if you are not able to handle, you can approach me at any time. I will be clearing your doubts. Okay, thanks for watching.